Let us study chemistry together with CBSE Chemistry Tips and Tricks.
In this section, we are going to discuss about the most important conversions for your board exam. Benzene to metabromophenol. First, we can draw the reactant and product. So, reactant is benzene, right? And what is the product? Metabromophenol. So, on benzene ring we have OH group. Now, it is phenol. Now, meta position you have bromine. Before starting the conversion, make a strategy to follow. See here, the strategy is you have to introduce a meta-directing group on benzene. So say NO2 group. Okay, then brominate it. So what will happen? On meta position, you will be getting bromine. Then convert the meta-directing group to OH group in minimum steps. Okay, let us start the conversion. So we have to start from benzene. Okay, now we are nitrating it because NO2 group is a meta-directing group, right? Okay, so we are nitrating it by adding HNO3 and H2SO4. So we got what? Nitrobenzene. Now brominate it by adding Br2 in the presence of FeBr3. Now bromine will be on meta position, right? Okay, now bromine is on the meta position. Now what is our task? To convert NO2 group to OH group. So that we cannot do in a single step. So for that purpose, first we have to reduce NO2 group by adding tin and HCl. So what we will get? We will be getting corresponding aniline, right? Okay, so NH2. And on meta position you have bromine, right? Now what we are doing? We are adding HCl and NaNO2. So what you will be getting? You will be getting diazonium chloride, right? Diazonium chloride. Correct? N2Cl, and here you have bromine. And you know how to prepare phenol from diazonium chloride, right? Add what? Warm water. Okay. So what you are getting? The N2Cl will be replaced with OH. On meta position you have bromine. And what is the product? Metabromophenol. We got the product, right? Metabromophenol. A simple but effective trick to find the higher homologue of alcohols, aldehydes, haloalkanes and carboxylic acid. So one trick, hundreds of conversions. By using this trick, you can find the higher homologue of carboxylic acid. See, RCOH become RCH2COH. Aldehyde become what? RCHO become RCH2CHO. See, amine RCH2NH2 become what? RCH2CH2NH2. Now haloalkane RCH2X become what? RCH2CH2X. Okay, so by using this method you can find the higher homologue of carboxylic acid, aldehyde, amine, alcohol and haloalkane. See, from all this carboxylic acid, aldehyde and amine, you can prepare alcohol. Now, on adding red phosphorus and halogen, you are getting corresponding haloalkane. Adding KCN, you are getting corresponding nitrile. And if you check, you can see on this step, one carbon is added up. You got the higher homologue already, right? Now, on adding LiAlH4, you are getting on reduction, you are getting what? Amine. And then adding all these reagents, you are getting alcohol. Once you get alcohol, you will get different types of product according to the reagents. Hope you understand. For understanding, we can do a question. Convert ethanoic acid to propanoic acid. Okay, see, it is regarding carboxylic acid. So start from carboxylic acid. Then you can follow this step and you will reach higher homologue of alcohol. Then higher homologue of carboxylic acid. Okay, let us try. So starting with ethanoic acid, what is that? CH3COOH, correct? Then what you have to add? Add LiAlH4, right? Okay, we can reduce it by using strong reducing agent LiAlH4. What you are getting? Corresponding alcohol CH3CH2OH. Then what you have to do? Red phosphorus and halogen. You are getting haloalkane, right? Okay, we can add red phosphorus and bromine. Okay, what you will get? CH3, CH2, Br. Then what we are doing? We are adding KCN to get corresponding nitrile, right? Okay, we can add it. We can add we can add KCN. So what we will get? CH3, CH2, Cn. See, one carbon is already added up. Correct? Okay, here you can see only 2 carbon and here you can see 3 carbon. So already carbon is added up, right? Okay, now reduce it by using LiAlH4. What you will get? You will get what? You will get amine, right? So what is that? CH3, CH2, CH2, NH2, right? Now what you have to do? See, you have to add all these reagents. You will be getting corresponding alcohol. Okay, we can do that. Okay, what are the reagents? HNO2 plus NaNO2 and HCl plus HNO2. And what you are getting? You will be getting CH3, CH2, CH2OH. And what is the last step? See, you have to add alkaline KMNO4. You are getting the higher homologue of carboxylic acid. Okay, we can do that. CH3, CH2, COOH. What is that? Propanoic acid. From ethanoic acid, we prepare propanoic acid. Ethanoic acid to propanoic acid. Okay, we can do one more example. Chloroethane to propanol. Chloroethane to propanol. See, we are not finding the higher homologue of haloalkane. Okay. See, we are starting with a haloalkane and we are finding an aldehyde with 1 carbon extra. So we can start from a haloalkane. You can follow the step. 1 carbon will be added up and you will be getting the corresponding aldehyde with 1 extra carbon. Understand, right? So starting with chloroethane, we are getting an aldehyde with 1 extra carbon. Hope you understand. Okay, so we can write chloroethane. What is that? CH3, CH2, Cl. Now what you have to do? See, we started from here. Okay, add KCN. So add KCN. What you will get? You will be getting CH3, CH2, Cn. We got 1 carbon extra. Now what you have to do? LiAlH4. You will be getting amine. Okay. Add LiAlH4. What you will get? CH3, CH2, CH2, NH2. Correct? CH2, NH2. Now what you have to do? You have to add all these reagents. You will be getting alcohol. Okay, we can add that. Okay, so what is that? NaNO2 plus HNO2 plus HCl plus H2O. What you will be getting? You will be getting like CH3, CH2, CH2OH. Now what do we have to find? We have to find aldehyde, right? Okay, propanol. Okay, so just oxidize it with CrO3. So what you will be getting? CH3, CH2, CHO. Understood, right? We can try one more question. Ethanamine to propanoic acid. Okay, so we are starting from amine and we are not directly finding the higher homologue of amine, but we are finding a carboxylic acid with 1 extra carbon. Ethanamine 2 carbon and propanoic acid 3 carbon, right? So we are starting from an amine. See, we will be following these steps, reaching the alcohol with 1 carbon extra, oxidizing with alkaline KMNO4, and you are getting the corresponding carboxylic acid. Hope you understand. Okay, we can start with ethanamine. CH3, CH2, NH2. How to convert to alcohol? See, step number 1, right? This one. Okay, so what you have to add? You have to add NaNO2 plus HNO2, HCl plus H2O. And what you will be getting? CH3, CH2OH. Now what you have to add? Red phosphorus and halogen, right? Okay. We are adding red phosphorus and bromine. But you are getting CH3, CH2Br, right? Now what is the next step? See, add KCN. So you will get the corresponding nitrile, 1 carbon extra, right? Okay, add it. We are adding KCN. What you will be getting? CH3, CH2, CN. What is the next step? See, you have to add LiAlH for reduction. You will be getting amine. So what is that? You will be getting like CH3, CH2, CH2, NH2. Now what you have to do? You have to add all these reagents. You will be getting corresponding alcohol. Okay, what is that? NaNO2 plus HNO2 and HCl plus H2O. What will you be getting? CH3, CH2, CH2OH. And what is the last step? Add alkaline KMNO4. You will be getting corresponding carboxylic acid. Correct, right? Alkaline KMNO4. So what is that? CH3, CH2, COOH. Hope you understand. By heart this trick properly, it will definitely help you to solve lot of conversions in organic chemistry. We are going to learn a simple and effective trick to find the lower homologue of alcohol, aldehyde, haloalkane and carboxylic acid. This trick is used to find the lower homologue of different functional group like aldehyde, amines, haloalkane, alcohol and carboxylic acid. Before that, what is lower homologue? Lower homologue means 1 carbon less. For example, propanol. What is the lower homologue? Ethanol. Ethanoic acid. What is the lower homologue? Methanoic acid. Understood, right? Now, how to use this trick? If you want to find the lower homologue of aldehyde, see, you have to start from here. This is aldehyde, right? Okay, reduce it to alcohol, oxidize it to carboxylic acid, then adding ammonia and heating you will get amide. Follow Hofmann bromide reaction, you will get amine. See, adding all these reagents you will be getting alcohol, then oxidation you will be getting what? The lower homologue of aldehyde. Similar way you can find the lower homologue of amines, haloalkanes, carboxylic acid and alcohol. Okay, for example, if they ask to find the lower homologue of carboxylic acid, start from here. Okay, follow the step. You will be getting the lower homologue of carboxylic acid. Okay, we can do some examples. Ethanamine to methanamine. So it's a question of amine, right? So start from here. Okay, then add all this reagent, you are getting alcohol. Oxidize it, carboxylic acid. Okay, add ammonia and heat it, you will get amide. Then see Hofmann bromide reaction, you are getting what? Amine of lower homologue. You have to stop here. Understood? We already got the answer, right? Once you reach here, you are getting the answer. Okay, we can try. Ethanamine means what? CH3, CH2, NH2. Now what we have to add? We have to add all these reagents, right? NaNO2 plus HNO2 plus HCl plus H2O. So you will be getting corresponding alcohol with the 2 carbons CH3, CH2OH. Now what you have to do? You have to add alkaline KMNO4, right? Okay, alkaline KMNO4, strong oxidizing agent. You will be getting what? Corresponding carboxylic acid with 2 carbon. Now add ammonia, heat it, removal of water. You will be getting corresponding amide. What is that? CH3CONH2. Correct? Now what you have to do? See, you have to follow Hofmann bromide reaction. Add Br2 in the presence of NaOH. Okay. So following Hofmann bromide reaction, what you will get? CH3NH2. What is that? That is methanamine, lower homologue. We got our answer. How is the trick? Hope you understand. We can do one more example. Propanol to ethanol. Propanol is alcohol with 3 carbon and ethanol is aldehyde with 2 carbon. Right. So it's about lower homologue. Correct. But with a different functional group. Okay. So we have to follow. See, starting from alcohol, you have to oxidize it, adding ammonia, heating, Hofmann bromide reaction, adding all this reagent, you are getting alcohol, and then oxidize it, you will get aldehyde. See, starting from here, and you have to end here, right? Okay, hope you understand. Once you understand the trick, then it is very easy, okay? Let us do it. Starting with propanol, CH3, CH2, CH2OH. What we have to add? We have to add alkaline KMnO4. Okay, we are adding alkaline KMnO4, and what we are getting? Corresponding carboxylic acid with 3 carbon, right? Okay, now we are adding ammonia and heating. Water is removed. We are getting what? Amide. CH3, CH2, CONH2, followed by what? Hofmann bromide reaction. Okay, you will be getting amine, correct? Br2 and NaOH. And you are getting what? CH3, CH2, NH2. Now already 1 carbon less, right? Now add all these reagents. You will be getting corresponding alcohol. So what is that? CH3, CH2OH. Now your alcohol contain only 2 carbon, okay? We start with 3 carbon, right? And our final step. We need what? Ethanol, aldehyde. So what you have to do? Oxidize it with CrO3. CrO3. You are getting what? CH3CHO. We got the final answer. One last example. Ethanol to methanamine. Okay, ethanol have 2 carbon. It is an aldehyde. Methanamine is amine but with 1 carbon. Understand, right? Functional group are different, but you can see that product contain 1 carbon less than the reactant. So you can use the lower homologue trick. Okay, starting with aldehyde, right? So start from here. Then reduce it, alcohol, oxidize it, carboxylic acid, adding ammonia, heating, losing water, you are getting amide. Then see, Hofmann bromide reaction, you will be getting the amine of lower homologue. You can stop the see conversion here, okay? You can stop it here. Hope you understand. So what is ethanol? CH3CHO. Then what do you have to do? See, reduce it, okay? We have to reduce it by adding H2 in the presence of palladium. You will be getting what? CH3CH2OH. Then what is the next step? Oxidize it with strong oxidizing agent, alkaline KMnO4. What you will get? CH3COOH. What is the next step? See, adding ammonia, heating, losing water, you will get amide. Okay, so add NH3, heating, losing water, you will be getting CH3CONH2. Now followed by Hofmann bromide reaction, right? This one. Okay, so Br2NaOH, you will be getting what? CH3NH2. So what is that? Methanamine. From ethanol we got methanamine. Okay, so this trick is very, very effective for finding lower homologue of different functional groups. Benzene to metanitroacetophenone. Before starting the conversion, we can draw the reactant and product. What is reactant? Benzene, right? Benzene. Okay, and what is the product? Metanitroacetophenone. Okay, so benzene. Now COCH3, meta position, you have nitro group. Before start doing the conversion, see, you have to make a strategy to follow. If you check the product, you can see acetyl group, right? So introduce acetyl group on benzene by Friedel-Crafts acylation reaction. So you will get what? Acetophenone. And remember, acetyl group is a meta-directing group. So very easy, just introduce NO2 group. So it will direct towards the meta position. Now we can do the conversion starting with benzene. Okay. Now Friedel-Crafts acylation reaction, right? You have to add CH3 COCl in the presence of anhydrous AlCl3, right? So what you will get? You will get COCH3 on benzene, right? That is acetyl group and it is a meta-directing group. So add what? HNO3 and H2SO4. Now HNO3 will provide what? NO2 group and it will be directed towards meta position. Correct. So we got the required answer. Meta-nitroacetophenone. Propan 2-ol to 2-methyl propan 2-ol. Before doing the conversion, we can write the reactant and product. What is reactant? Propan 2-ol. So CH3 CH OH CH3. What is the product? It is 2-methyl propan 2-ol. So what is that? CH3 C CH3 OH CH3. Before start doing the conversion, make a strategy to follow. See here, what is a strategy? Here our task is to prepare what? Tertiary alcohol from secondary alcohol. See, hope you understand what is tertiary alcohol and secondary alcohol. Tertiary alcohol means OH is connected to this carbon, right? That is further connected to how many carbon? 1, 2, 3. So tertiary. OH is connected to this carbon, right? That is further connected to how many carbon? 2 carbon. So secondary. Hope you understand what is the meaning of secondary and tertiary. Also note, there is one extra carbon in the product side. If you check the reactant side, you can see 3 carbon, right? 1, 2, 3. And here how many? 1, 2, 3, 4. Correct? So this will be our flow chart. Okay. Secondary alcohol you have to convert to ketone. And you know, if you add Grignard reagent to ketone, you will be getting tertiary alcohol, right? Okay, let us do the conversion. So starting with CH3, CHOH, CH3. First we are oxidizing it by adding copper at 573 Kelvin. You will get ketone. Right, secondary alcohol undergo oxidation to give ketone. Now, see our ketone contain how many carbon? 3, right? And our product contain how many carbon? 4, correct? 1, 2, 3, 4. So, you have to add a Grignard reagent which contain one more carbon, 3 plus 1, 4. Okay, so CH3 MgBr. And see, you have to add H3O plus. So what you'll be getting? You will be getting CH3, CH3 like this and OH, and that is our required product. So we got the answer, but if anybody have confusion regarding how we get this product from ketone, listen here, I will explain it in detail. So we got ketone and we add what? CH3 MgBr. Now what will happen? This bond will shift towards here. Oxygen become negative, carbon become positive. This bond break, this become negative, this become positive. Now this C minus will be attached to the C plus and MgBr will go towards O minus. So what you will get? CH3, this one. Then that positive charge carbon take CH3, correct? Now on oxygen you will be having what? MgBr, and you have a CH3 here. Now what we are doing? Adding H2O in the presence of H plus, that is H3O plus, right? Okay, we are adding water in the presence of H plus. Now this bond break. Oxygen become negative, Mg become positive. This bond break. Hydrogen become positive, OH become negative. Now O minus will take this H plus. MgBr will take this OH minus. So what you will get? You will be getting the final answer, that is 2-methyl propan 2-ol. See, CH3. Now that oxygen take the hydrogen, it become OH. then CH3. Now Mg will take what? OH. Right, so MgOH Br. Hope you understand. See, this is the method. Okay, this is the method by which we got the final answer. Propanone to propene. First, we can draw the structure of reactant and product. Propanone is a ketone, right? CH3, CO, CH3. And we are supposed to convert to what? Propene, CH3, CH, double bond, CH2. Before writing the answer, try to make a strategy to follow. See, here you have ketone, right? And we are supposed to prepare alkene. Okay, and you know it is very easy to prepare secondary alcohol from ketone by reduction, right? And from alcohol, you know how to prepare alkene by dehydration. So it's very easy. Ketone to alcohol, alcohol to alkene. We can try, right? So we start with what? Propanone, CH3, CO, CH3. We are using reducing agent LiAlH4. Okay, and what we are getting? Secondary alcohol, right? CH3, CH, OH, CH3. Now what we have to find? What we have to get? Alkene, right? So you have to use dehydrating agent. What is that? Concentrated H2SO4. And what you will be getting? CH3, C, H, double bond, CH2. Correct, right? See, OH from here and hydrogen from here. Together H2O will be removed out. And a double bond will establish here. Hope you understand. Benzoic acid to benzaldehyde. We can draw the reactant and product. Benzoic acid means on benzene ring we have COOH, right? And benzaldehyde means what? On benzene ring we have CHO group. Before start writing the answer, try to make a strategy to follow. See, here it is very easy. If you remember all the preparation methods of benzaldehyde, this conversion become very easy. See, okay, so you remember from benzoyl chloride, you can prepare benzaldehyde. And it is very easy for preparing benzoyl chloride from benzoic acid, right? Okay, we can do the conversion. We start with benzoic acid, right? Now we are converting it to benzoyl chloride by adding SOCl2. Okay, so we are getting what? Benzoyl chloride. Then see, Rosenman reduction, you remember, right? Okay, you have to follow the steps of Rosenman reduction. Okay, and what you will get? You will be getting benzaldehyde. See this steps, okay? This is from Rosenman reduction, which you are supposed to by heart. Okay, Rosenman reduction. Ethanol to 3-hydroxybutanol. First we can write the reactant and product. What is ethanol? CH3 CHO, right? And what is 3-hydroxybutanol? CH3 CH OH CH2 CHO. Before start writing the conversion, make a strategy to follow. See here, if you check the product, you can see CHO group, okay, right? And OH group. If CHO group and OH group is there in product, 99.99% the question is about aldol condensation. And remember, for aldol condensation, what is the reagent? Dilute NaOH, that you keep in mind, okay? Okay, so we can check, okay? So we start with what? CH3 CHO, correct? So this is the first molecule of ethanol. See, I am using another molecule of ethanol, okay? So CH3, same ethanol, okay? CH3 CHO. Now you remember how aldol condensation take place, right? See this bond shift towards here, that become what? That become negative, this become plus. Okay, now this bond shift towards here, hydrogen become plus, carbon become negative. Now oxygen take this H plus, right? Okay, so what you will get? You will be getting like CH3, C plus, okay, C plus is there, keep it there. Now that O minus take that hydrogen. Okay, already there is a hydrogen on carbon. Now the C plus and the C minus make a bond, correct? Now on that carbon you can see 2 hydrogen and then CHO. That is our product, right? 3-hydroxybutanol. Hope you understand. So what is the hint? If you see aldehyde group or ketone group with OH group in the product, see mostly 99.99 case, what should be that? The question is about aldol condensation, cross or self. Okay. I forgot to put NaOH. Aldol condensation happens in the presence of NaOH. Okay, NaOH. That is very, very important. Chloroethane to butane. First we can write the reactant and product. So here what is the reactant? Chloroethane, right? CH3, CH2, Cl. And what is the product? Butane. CH3, CH2, CH2, CH3. Before writing the answer, make a strategy to follow. See, check the question properly. You can see that reactant is what? Alkyl halide, right? And if you check product, you can see that you can see a hydrocarbon with double the number of carbon than the reactant. Here 2 carbon, haloalkane, and here 4 carbon, hydrocarbon. In that case, in such cases, without wasting time, go for Wurtz reaction. What is Wurtz reaction? See CH3, CH2, Cl. Here 2, here 4, right? So use 2 molecules. Now, what is the reagent? Sodium. In the presence of what? Dry ether, right? You will be directly getting what? CH3, CH2, CH2, CH3. All of you remember Wurtz reaction, right? What is that? Rx. Okay. Plus Na plus Na plus Rx is equal to, see this R and this R combined together. So what is that? RR. So product contain double the number of carbon than the reactant. Now see this Na and X combined together, right? You will be getting NaX, and this Na and X combined together you will be getting again NaX. So 2 NaX. Understood, right? So CH3 CH2 become double. You can see that. And what is the byproduct? NaCl. For conversion that is not very important, but if you want you can write. You will be getting NaCl, 2 NaCl, okay. Benzoic acid to aniline. Before writing the conversion, first we can write the reactant and product. What is the reactant? Benzoic acid, right? Benzoic acid. Okay. And from benzoic acid, what we are preparing? Aniline. We are supposed to convert benzoic acid to aniline. Before starting to do the conversion, we have to plan a strategy to follow. If you check the reactant, you can see COH group, which contain 1 carbon. And if you check the product side, you can see there is amine group, which does not contain carbon. So our first primary task is to remove COH group. And for that purpose, the best way is what? Decarboxylation reaction. You remember decarboxylation reaction? See, this is decarboxylation reaction. See, the salt of carboxylic acid in the presence of NaOH and CaO, you are getting RH. Correct, right? Removal of CO2 is actually happening here. See, for example, just for understanding, CH3COONA plus NaOH. In the presence of CaO, you will be getting like CH4. Understood? See, here you have 2 carbon and product contain only 1 carbon, right? Okay, of course, plus byproduct will be there. It is Na2CO3. So, what we have to do here? See, from carboxylic acid, you have to make a salt. Just like you have to add NaOH, you will be getting a salt of carboxylic acid. Right? Then by using decarboxylation reaction, you can prepare benzene ring, right? From benzene, if you nitrate, what you will get? You will get nitrobenzene. And nitrobenzene, on reduction, you will get what? Aniline. So you got a strategy, right? From benzoic acid, make a salt. From that, you can prepare what? Benzene. From benzene, you can prepare nitrobenzene. From nitrobenzene, you can prepare aniline. Okay, we can start. See, we start with benzoic acid. So we are adding sodium to it. So we are getting the salt, right? We are getting the salt, COONA. Now what we are adding? We are adding NaOH and what? CaO. Decarboxylation reaction. You are getting what? You will be getting like this. But no need to show that hydrogen, right? Because it is what? Benzene ring only, correct? Okay, so we got benzene ring. Now just nitrate it. How? By adding HNO3 and H2SO4, correct? So we nitrate it, correct? Now you know how to convert nitrobenzene to aniline. Add tin and HCl. Reduction, right? On reduction, you will be getting aniline. Hope you understand. Benzamide to toluene. First, we have to draw the product and reactant, okay? See, what is benzamide? Benzamide is benzene ring, then CONH2. And what is toluene? Toluene is a very common compound, right? What is that? On benzene ring, you have CH3. Correct, right? Before start doing the conversion, you have to make some strategy to follow. See here, if you can prepare benzene from amide, then you know you can easily convert benzene to toluene by using Frederick-Kraft alkylation, correct? Okay, now is there any method to prepare benzene from amide? Of course. See, you have an aromatic amide here, right? If you use Hofmann-bromamide reaction, it become what? Aniline, correct? Now, see, it is very easy to prepare diazonium chloride from aniline. And you know from diazonium chloride, of course, you can prepare what? Benzene, correct? Now we can try. So, we start from benzamide. How to convert to aniline? See, Hofmann-bromamide reaction, right? Br2 in the presence of NaOH, you will be getting aniline. Remember, here you are getting a product which contain 1 carbon less. Okay, here you can see 1 carbon here, and in product you cannot see that. Okay, now next step, what we are doing? You are converting it into diazonium chloride. How to convert it? By adding NaNO2 and HCl, right? Okay, so what you are getting? Benzene diazonium chloride, correct? Okay, now we reach benzene diazonium chloride. How to convert to benzene? See, it's a direct textbook reaction, okay? Add H3PO2 in the presence of water. What you will get? You will be getting benzene as the main product. Now we got benzene. How to prepare toluene? Very easy. Frederick-Kraft alkylation. So what you have to add? Add CH3Cl in the presence of anhydrous AlCl3. What we will get? We will get toluene. Okay, we are getting the required answer. We start with benzamide. It undergo Hofmann-bromide reaction. We got aniline. Then see, it become diazonium chloride. Then we add H3PO2 and H2. It become benzene. And Frederick-Kraft alkylation reaction, you got toluene. Okay, we got the required answer. Ethyl magnesium chloride to propan 1-ol. First we can write the reactant and product. Okay, what is reactant? Ethyl. Ethyl means what? CH3, CH2, magnesium chloride. Correct? And what is the product? Propan 1-ol. What is propan 1-ol? CH3, CH2, CH2, OH. Before doing the conversion, you must definitely know this hint. Grignard reagent plus methanol gives primary alcohol. Okay, and also you have to cross check the number of carbons. Okay, see in Grignard reagent how many carbon is there? 2. Okay, and primary alcohol how many? 3. So 2 plus 1, 3. Okay, so it is perfectly fit there. Now we can do the conversion. So the Grignard reagent is what? CH3, CH2, MgCl. Correct? It is reacting with what? Methanol. What is methanol? HCHO. Correct? Okay, now how the reaction happens? See, this bond shift towards here. Oxygen become negative, carbon become positive. This bond will break, C become negative, Mg become positive, and this C will go towards this carbon, Mg go towards oxygen. Correct? And what you will be getting? See, you will be getting, see, first I am writing this, okay, this part. So I am writing on that carbon, H is there. Correct? Okay, and it carry what? A positive charge. Correct, right? On that carbon who is coming and attaching? CH2, CH3. Correct? Now on oxygen who is attaching? O, MgCl. Understood, right? Now I am writing it in a proper way. See, CH3, CH2, CH2, OMgCl. Hope you understand. So we can write like, first I am writing this CH3, okay, this CH3, then I am writing this CH2, okay, CH2, then I am writing this CH2, okay, CH2, then what? OMgCl. Now what is the last step? See, you have to add water, H2O or HOH in the presence of H plus, okay. Now what will happen? See, this bond will break. This bond break. H become H plus, O become O minus. This bond will break. Mg become Mg plus and O become O minus. Okay. Then this H plus will be taken by O minus and OH minus will be taken by MgCl. So what you are going to get? CH3, CH2, CH2, that O minus take H plus. So it become OH. And what is the byproduct? Mg is taking OH, right? So MgOHCl. Byproduct is not very important for conversion. So this is our required answer. CH3, CH2, CH2OH. One important thing, see, these two are same, right? This I rearrange and draw like this. This is not a reaction. See, I rearrange this in a proper way. Okay, so no need to represent it twice. Okay, so you can just cut this part. Okay, directly connect this. You understand what I'm saying? So the reaction is like this. We start with ethyl magnesium chloride. We add what? Methanol. We got an intermediate. Okay, we add water and we got the final product. What is final product? Propan 1-ol. Benzoic acid 2 meta-nitrobenzyl alcohol. Before start writing the conversion, we can write the reactant and product. What is the reactant? It is benzoic acid. Okay. Now, what is the product? Product is, see, on meta position we have nitro group, right? Meta-nitrobenzyl alcohol. Okay, CH2OH, and on meta position we have NO2 group. Okay, so we write the reactant and product. Before start writing the answer, try to make a strategy to follow. Okay, here you have NO2 group on meta position, right? And we know COOH group is a meta directing group. So it's very simple. You can directly nitrate it. So what will happen? On meta position you will be getting NO2. Then what is the next task? COOH group is supposed to convert to alcohol. that you can use a strong reducing agent like LiAlH4, right? Okay, let us convert. So we start with the benzoic acid. We are going to nitrate it by adding what? HNO3 and H2SO4. Okay, so we got what? Metanitrobenzoic acid, right? COOH and NO2. Now, what we are going to do? We are going to convert CCOH group to CH2OH by using a strong LiAlH for strong reducing agent. Okay, so what you will be getting? You will be getting C on COH group. Instead of COH group, you will be getting CH2OH, and meta position already you have NO2. And remember, LiAlH4 does not reduce NO2 group. Okay, so we start with benzoic acid and we got metanitrobenzyl alcohol. Chlorobenzene to salicylaldehyde. Before starting the conversion, we can write the reactant and product. What is reactant? Chlorobenzene, right? Chlorobenzene. Okay, now we are converting it into salicylaldehyde. What is that? See, we already know, right? It is actually the product of Raymer-Tiemann reaction. You remember it? OHCHO. When you see a conversion with salicylaldehyde as the product, you have to remember one important point. This salicylaldehyde is the product of Raymer-Tiemann reaction. And what is the reactant of Raymer-Tiemann reaction? That was phenol, right? So, if you can prepare phenol from chlorobenzene, then you can follow Raymer-Tiemann reaction to get the required answer. Hope you understand. Now we can do the conversion. We start with chlorobenzene, right? We start with chlorobenzene. Now how to convert to phenol? See, at a pressure of 300 atm and at a temperature of 623 Kelvin and NaOH, what you will get? You will be getting, see, sodium phenoxide, right? Now adding H plus, on adding H plus, you will be getting phenol. Now we have to follow Raymer-Tiemann reaction. Once you get phenol, just copy the steps of Raymer-Tiemann reaction, which you already know. You already by hearted that name reaction, right? Once you get phenol, just copy the steps of Raymer-Tiemann reaction and you will get salicylaldehyde. Propanone to 2-methyl propan 2-ol. So this is a structure of propanone, which is a ketone, right? And this one is a structure of propan 2-ol, which is a tertiary alcohol, correct? Now remember this hint. If the question is to prepare tertiary alcohol from ketone, you use this hint. Okay, ketone plus Grignard reagent, you will be getting tertiary alcohol. Okay, the only thing you have to take care is the number of carbon in the product. If you check the reactant, you can see how many carbon? 1, 2, 3. And if you check product, you can see how many carbon? 4, right? 1, 2, 3, 4. Which means the Grignard reagent you are going to add must contain only 1 carbon. Let us convert. So propanone is what? CH3, C double bond O, CH3, right? Now you have to add a Grignard reagent which contain 1 carbon. What is that? CH3 MgBr, right? Now how the reaction proceed? See, this double bond shift towards oxygen. Okay, so oxygen become negative, carbon become positive, right? This bond will break. This become negative, this become positive. Now this negative charge carbon will come towards positive charge carbon. Now positive charge Mg will move towards the negative charge oxygen. So what you'll be getting? Check and say CH3 on this carbon carrying positive charge, you will be having CH3, right? So CH3. Now oxygen carrying negative charge, make a bond with MgBr, right? And what is left? CH3. Hope you understand. Now what is the final step? Addition of water in the presence of H plus. What is water? HOH. Okay, now what is the product? You will be getting like CH3 COH CH3 CH3. That is the required answer, right? 2-methyl propan 2-ol. And how it happens? See this bond, okay? This bond will break. H become plus, OH become minus. Now this bond will break. O become minus, Mg become plus. Now this H plus, okay, this H plus is taken by the O minus. You are getting what? You are getting OH. Now this MgBr plus combined with OH minus, you will get the byproduct. What is that? MgOHBr. Writing the byproduct is not very important for conversion questions. Okay. So we start from ketone. Ketone contain 3 carbon and our required product contain 4 carbon. So we are adding a Grignard reagent which contain 1 carbon. 3 plus 1, 4, right? Okay, now we know ketone plus Grignard reagent we will be getting a tertiary alcohol. See, this will be your intermediate. On adding water, you are getting the final product. This is byproduct, but for conversion questions, writing byproduct is not very important. 1 bromopropane to 2 bromopropane. First, we can draw the structures of product and reactant. So 1 bromopropane means what? CH3, CH2, CH2, Br, right? And 2 bromopropane is what? CH3, CH, Br, CH3. Correct, right? Before start writing the answer, make a strategy to follow. See here, if you check this particular carbon, you can see a bromine on it, right? But on product side, you cannot see that bromine. Now coming to this carbon, you can see 2 hydrogen, but on product side, you can see only 1 hydrogen. So you are supposed to remove this bromine and one of the hydrogen from here, right? Bromine and hydrogen from adjacent carbon. So what is the reaction? Dehydrohalogenation. For dehydrohalogenation, what is the reagent? Alcoholic KOH. So what will happen? This bromine and one of the hydrogen will be removed out and a double bond will establish between that 2 carbon, right? So what is that? CH3, CH, double bond, CH2. Now what is our next task? We have to add 1 bromine on this carbon and 1 hydrogen here, right? For that purpose, you can simply add what? HBr, right? So that it will follow what? Markovnikov rule. Markovnikov rule. What is Markovnikov rule? According to Markovnikov rule, hydrogen will move to the double bonded carbon which carry more number of hydrogen, and bromine will go to the carbon which carry lesser number of hydrogen. So what you will get? You will get CH3, CHBr, CH3. Correct, right? So we start from 1 bromopropane and end with what? 2 bromopropane. So on first step, to remove hydrogen and bromine from adjacent carbon, we use alcoholic KOH. The reaction is known as dehydrohalogenation. So we got the alkene. Then we add HBr. Okay, and it follow Markovnikov rule. So hydrogen will move to the carbon which carry more number of hydrogen, and bromine go to the carbon which contain lesser number of hydrogen. Okay, and we got the final answer, that is 2 bromopropane. 1 bromopropane to 2 bromopropane. First, we can draw the structures of product and reactant. So 1 bromopropane means what? CH3, CH2, CH2, Br, right? And 2 bromopropane is what? CH3, CH, Br, CH3. Correct, right? Before start writing the answer, make a strategy to follow. See here, if you check this particular carbon, you can see a bromine on it, right? But on product side, you cannot see that bromine. Now coming to this carbon, you can see 2 hydrogen, but on product side, you can see only 1 hydrogen. So you are supposed to remove this bromine and one of the hydrogen from here, right? Bromine and hydrogen from adjacent carbon. So what is the reaction? Dehydrohalogenation. For dehydrohalogenation, what is the reagent? Alcoholic KOH. So what will happen? This bromine and one of the hydrogen will be removed out and a double bond will establish between that 2 carbon, right? So what is that? CH3, CH, double bond, CH2. Now what is our next task? We have to add 1 bromine on this carbon and 1 hydrogen here, right? For that purpose, you can simply add what? HBr, right? So that it will follow what? Markovnikov rule. What is Markovnikov rule? According to Markovnikov rule, hydrogen will move to the double bonded carbon which carry more number of hydrogen, and bromine will go to the carbon which carry lesser number of hydrogen. So what you will get? You will get CH3, CHBr, CH3. Correct, right? So we start from 1 bromopropane and end with what? 2 bromopropane. So on first step, to remove hydrogen and bromine from adjacent carbon, we use alcoholic KOH. The reaction is known as dehydrohalogenation. So we got the alkene. Then we add HBr. Okay, and it follow Markovnikov rule. So hydrogen will move to the carbon which carry more number of hydrogen, and bromine go to the carbon which contain lesser number of hydrogen. Okay, and we got the final answer, that is 2 bromopropane. Convert benzene to metachloroaniline. First, we can draw the reactant and product. So what is the reactant? Benzene, right? So benzene. Okay, and what is the product? Product is metachloroaniline. So we have aniline, NH2 group, and then we have meta position chlorine. Before starting conversion, see, we have to make a strategy to follow. See, if you check, you can see chlorine on meta position. Okay, so we need a group here which is meta directing, and that group is supposed to convert to NH2 group in the next step. Do you know any meta directing group which can easily convert to NH2? Of course, NO2 is there, right? NO2 is there. You know nitrobenzene undergo reduction in the presence of lead and HCl to give aniline, right? Okay, so we can do that. So we start from benzene. First you have to nitrate it, HNO3 and H2SO4. We got nitrobenzene, correct, right? Now nitrobenzene is meta directing group. Just chlorinate it. What you have to do? You can add Cl2 and FeCl3, correct? See, on adding you will be getting what? You will be getting, see, meta position. You can get chlorine, right? Now what we are doing? See, we are going to reduce NO2 group by adding what? By adding tin and HCl. So what you are getting? You are getting, see, meta position, you have chlorine. So what is the name of the product? It is metachloroaniline. Very easy, right? First we introduce NO2 group. For what purpose? For directing the chlorine to the meta position. After that, see, NO2 group is replaced by what? NH2 group. So that we are getting metachloroaniline.